6.5. So, you know, that's kind of the spread of 3 different models for computing Secchi depth from the in-water light field, and then it tells you how long it took. Okay, the other way to look at the output is the Excel spreadsheets. So there's a multi-wavelength and a single wavelength. The multi-wavelength spreadsheet here, we open that guy up. What it has is each page of the spreadsheet is one variable, absorption, scatter, backscatter, ED, whatever, but it's at all wavelengths and depths. The single wavelength spreadsheet has the same information, but one page will have like all the IOPs, one page will have all the AOPs and such, and there will be a block for the first wavelength, then a block for the second, a block for the third. So it's ordered wavelength by wavelength, and I never ever used that, but it's there. So if you wanted to look at, let's say, the ED and the water, okay, here it is in the air, just above the surface, the values in the water, wavelength by wavelength. Or if you wanted to look at, let's say, remote sensing reflectance, well, there's that form, and you could just plot out, you know, here's remote sensing reflectance, and add a plot here, and there's your spectrum. Now, one of the reasons I don't use Excel is Microsoft, with like hundreds of billions of dollars a year in revenue, cannot hire somebody that can look at my data and say, oh, it starts at 405 and it ends at 700. Maybe I should start the plot at 400 and end at 700. That's just beyond them. But my IDL programs are so clever, they can look at the data and say, oh, maybe we should do 400 to 700. So anyway, it takes you like 5 seconds to generate the plot, and then 5 minutes to screw around with the axes and stuff to try to get a plot that looks halfway presentable. So anyway, at this point, you're just in Excel. It has nothing to do with Hydrolight, and you can use it or not. So enough said there. Time to turn you guys loose here. And so here's what we have for suggested problems. So the first one, you just learned about optical depth, running that little constant IOP model. There's one where, let's say you have an IOP, like absorption is some value, and now the question is, well, maybe it's 20% bigger, it's 20% smaller. What's that going to do to my light field? Well, you can do like a run with, say, A of 0.3, and then a run with A of, 0.25, and a run with A of 0.35 or something. See what happens. There's one to play around with how RRS really depends on BB over A. You know, you can do different phase functions and such, won't make a whole lot of difference. There's this classic and new IOP models. In theory, you put in chlorophyll, you would get the same thing out. In reality, of course, there are different ways of converting chlorophyll into absorption and scattering, and they won't give the same answer. And there's one to just convince yourself that Hydrolight and Ecolite give the same output, and so on. So let me just pass these guys out.